A very good morning. In this particular video lesson, I would like to give you the information regarding what is seed, then quality characteristic of the seeds, and difference between seed and grain, and the difference between seed production and crop production. Because these are all the basic things. If you are well versed with these aspects, we can easily understand the remaining part of that seed science and technology course very easily. So let us start with defining that seeds. So what is a seed? So seed is a mysterious source of life of a plant. Yes, without seed we cannot think of establishment of a next generation crop. So seed is a miniature plants, or otherwise it is called as a dormant plant or a mutant of the plants. And also seed is a viable one. So like that of the human being, the seed also respire and metabolically active even after harvest from the mother plant. So this also respire. So this need to be respire because each and every seed that possesses an young poetus within them in the form of a embryo in the case of monocot, or in the form of primary embryonic axis connected with the cotyledon in the case of a dicotyledon plant. And also this have a hidden forces with reference to its own development, and that also have its nutrient elements for its take care of its protein metabolic activity, and this have its own life. So these are all the things with reference to seed is content. Apart from that, this also self-contained. The seed itself designed to disperse and scatter using other forces of nature, that means scattered through the wind or water or insects or animals. So these are all the main point with reference to seed is concerned. In agriculture point of view, seed is the cheapest input and main input. So this is the only living input we are using for crop production purpose. So the other inputs like fertilizers or insecticides or pesticides and even soil, everything we are using, but they don't have a life. So this is the only living input we are using for crop production, that also cheapest one. And fertility of the other inputs in the crop production is mainly rely upon the quality of the seed used for crop production purpose. Good seed is in good soil realize always very good yield, and the wealth of the farmer as it is yesterday's harvest and tomorrow's hope. Yes, today whatever the thing we are going to harvest as a seed, tomorrow we are going to use that material as a source seed for raising of the next generation crop. So because of that, yesterday's harvest and tomorrow's hope, that is seed. In social and economic function of the seed is concerned, seed act as a carrier of new technology. Yes, whatever the technology we are trying to infuse into the plant system for the purpose of insect resistance or disease resistance or quality thing, all those things will be at the end of the maturity deposited in the seeds. So if you sow that seeds, again that seed will give rise plant. That plant will have all the character of the mother plants, regular character, in addition to through our transgenic technology or genetic engineering modification technology, whatever the technology we introduce into the plant system, that also will be available in the next generation, that is through the seed. So seed acts as a carrier of new technology. Then seed is a basic tool for secure food supply. Yes, so if you have a seed, if at all any natural calamities, you can by the way of sowing the seed, you can have a crop. Suppose you don't have a seeds, after that natural calamities mean there is no chance for re-establishment of the all our food crops. So seed is a secured source for our food supply, and also rehabilitation of the agriculture, that is rapid rehabilitation of the agriculture in the case of natural disaster. And seed act as a less favorable production area. Principal means to secure crop yield. Yes, if we sow seed under very poor soil, there also some crop establishment. From that crop we can harvest some material. But without seed, without sowing any seed, if you apply any fertilizer or insecticides and any other inputs, we cannot have crops. So this is an principal means to secure a crop yield. Then good quality seed will respond more to fertilizer and other inputs. So develops other industrial development also. So good quality seed that will develop a plants and that always respond very well to the other fertilizers, pesticides, crop nutrients, all those things. Once the farmers realize that fertilizer responsive nature of the seed and the crop, automatically they started to demand other inputs. So at the time, other industry will start up. So everything is based on the seed only, that other industries also will develop. The seed from only a small part of the total cultivation expenses, but it will pay dividend towards the yield. So actually for purchase of the seeds, we will spend a little amount of money, but quality seeds that will yield more. So that is a point I wanted to convey here. So with that we can see some of the definition given by the various biological field. In that, the first definition is given by the botanist. So in the botanist point of view, seed is an embryonic plant together with the stored food surrounded by the, actually this is given by the structural biologist. First we can discuss that structural biologist definition, then we can move to that botanist direction. So the structural biologist point of view, seed is an embryonic plant together with stored food surrounded by the protective coat. Yes, embryonic plant means, so as far as seed is concerned, we have two type of seeds. So that classification is mainly based on the number of cotyledon available in the seed. So one type of seed is a monocot, another type is a dicot seeds. Example for monocot seed is almost all your cereals, so that is a paddy, wheat, oat, all those things will come under that particular category. So that there are only one cotyledon, that cotyledon also very much reduced. Moreover, whatever that cotyledon tissues are available at the time of development, so all those things and all utilized by the developing endosperm. So the monocot that will have only endosperm alone. So that only one cotyledon will be available, that also very much reduced. So the reduced form of cotyledon is known as scutellum. So in the case of monocot, cotyledon is available in the form of scutellum. So monocot that will have a embryo, whereas in the case of dicot that have a two cotyledon. Example for dicot is almost all your pulses and oil seeds and other crops also there. And the seed structure identification class, I will tell you more example for these two category. The dicot that have a two cotyledon, that any one of the cotyledon that will have one projection, that is a primary embryonic axis. So in the case of dicot, the primary embryonic axis that will have a tissues corresponding to the root and shoot development. Similarly, in the case of monocot, the tissue related to that root and shoot development that will be available in the case of embryo. So because of that, the structural biologists, they are mentioning this word embryonic plant. Embryonic plant means it's an embryo. In the case of monocot, it's embryo. In the case of dicot, it's the primary embryonic axis. Then the another word they are using, together with the stored food. Yes, all the seeds are given with storage organ. That storage organ, particularly in the case of monocot, the endosperm act as a storage organ. So whatever that photosynthesis given by the mother plant, that will be accumulated in the endosperm area. So food reserves are there in the endosperm area. And another main point here is the endosperm, it's a non-living tissues. As far as that monocot is concerned, that have a embryo and endosperm. That embryo have the tissues related to that root and shoot development, or otherwise embryo is called as a miniature plant. So the embryo is a living part, whereas the endosperm available in the monocot is a storage organ, it's a totally a non-living. Similarly, in the case of a dicot that have a two vital organ, that I already told you. That is a primary embryonic axis and two cotyledons. So here that cotyledon act as a storage organ. Here that cotyledon as well as primary embryonic axis, both of them are living in nature. So because of that they included embryonic plant together with stored food. So all the seeds are given with some amount of the stored food. The biochemical composition of the stored food may vary from crops to crop. Say example, cereals that will have more carbohydrate, pulses that will have a little bit 20% protein content, whereas oil seeds that have a higher amount of the oil content. Like that, the chemical composition of the stored food may vary, but all the seeds are given with some amount of the stored food. Here one exception also there, that is orchids. The orchids are totally devoid of any storage organs, so that is a unique seeds. So because of that, for raising up that particular orchids, always we need to place the seed in the artificial nutrient medium. We have to give our nutrients, then only we can make that orchid seed also germinable one. Then the third thing they given is surrounded by a protective coat. Yes, almost all the seeds are surrounded by a external covering. So in the case of green gram, you can see a green color covering. In the case of black gram, you can see a black color covering. So that is known as a seed coat. So almost all the seeds are surrounded by a protective coat. Some other cases only one coat alone is there. Some other cases more than one coat also available. In the case of black gram, green gram and groundnut and all, only one covering, whereas in the case of cotton and all, three coverings will be there. Similarly, in the case of sunflower, the outer side black color, if you remove that black color husk, on inner side one white covering will be there, white leathery covering will be there. So like that number of protective coat available in seeds are vary from seeds to seeds. But anyhow, the structural biology point of view, the seed is defined as embryonic plant together with stored food surrounded by a protective coat. Then I am coming to that definition given by the botanist. So based on the botanist point of view, the seed is defined as it's a fertilized and matured or ripened ovule. So normally the ovules will be available in the ovary. Ovary is a female reproductive organ. Within that ovary, the ovule will be available. The ovule, some of the tissues of the ovule that develop into an embryo sac. So that embryo sac alone going to have a egg. That egg after fertilization develop into an embryo. So here the seeds are developed from the ovule. So the ovules after fertilization that will form a seed, pucca seeds. Whereas the ovary that will give rise a fruits. So from the ovary we can get a fruit, but from the ovule alone we will get the seeds. So because of that, and the botanist point of view, the definition for seed is it's a fertilized and matured ovule. The third definition given by the genetics. So based on their point of view, seed is defined as a mutant. Mutant means it's a miniature plant. So say example, it is a banyan tree. Once that banyan tree form the fruit and the seed is developed, that much bigger size banyan tree going to be there within the seed in the form of embryo. So it's a hardly very less than millimeter in size. That seed is less than millimeter in size. Within that total tissues corresponding to that entire banyan tree development going to be there. So because of that, they are defining seed as a mutant. Then another things also they are giving dormant plant. Yes, even though the tissues related to that root and shoot development is available in the form of embryo, and also embryo also well connected with the nutritive tissues, that the seed remain in a seed form as long as they are they are there in the story. Whenever you go for sowing up that seed in ideal conditions, at the time only the metabolic activity get activated and started to produce that root and shoot. So during storage, that remain metabolically less active. I can't say it's inactive, less active. So the minimum biological process like respiration, those things will occur, but that will remain in the form of a seed. So because of that, they are giving, they included that word also, dormant, mutant and dormant. Those things also they are giving. They act as a link between two generations. So this is a more appropriate as far as that seed is concerned, because whatever you are going to harvest from the mother plant, that is the output with reference to that mother plant crop is concerned. The harvested produce will be used for sowing, so that is the input for raising of the next generation crop. So now here, for the connecting link between the mother plant and the next generation is the seed. So because of that, seed act as a connecting link between the two generations. Apart from transfer of technology, so this act as a connecting link between two generations. So these are all the definition given by the scientific community on usage. What the farmers they are trying to give a definition for seeds. Simply they are telling it's a propagating material. So this is for further crop production. So farmers point of view, the seed is defined as a propagative material. Then another thing, we have our own seed act. So legislative procedures. So each and every country they must have some legislative regulation with reference to that seed is concerned. So in that angle, India also have legislative things in the name of Indian Seed Act 1966. In that 25 different sections are there. So each and every section that deal about various things related to that seed production, processing, testing, and everything is there. In that section 2, that is mainly give information regarding definition for various terms related to that seed. It may be seed production or seed testing, or definition for the person involved, the regulation of that seed production activities and the sales of that seed production activity. So all those things available in that they given definition for seed also. So based on Seed Act, and the definition for seed is not only as a conventional reproductive part of a plant, but also include all plant parts such as tubers, bulbs, rhizomes, roots, cuttings, graft, and other vegetative propagules of the food, fiber, fodder crop, as which we are used as base material for mass multiplication. In short, that seed act that include all the materials used for propagation purpose, they are considering as a seeds. Okay, so they are not considering seed alone is a seed. Apart from seeds, whatever that material like tubers, bulbs, rhizome, cuttings, and whatever that material, either vegetative or sexually produced materials are used for propagations, so everything they are considering as a seeds. So this is the thing. So these are all the definition given by the various scientific community as well as that legal thing. So next we are going to discuss about what is seed science. Seed science is any material used for mass multiplication for the purpose of reproduction is known as a seeds. So see, this is a definition given by the seed scientist. So actually any material used for mass multiplication for the purpose of reproduction is known as a seed. So this particular thing is given by the seed science. So now we are going to know the definition for seed science. So actually seed science is not a separate science, because it involves various activity. So that start from seed to seed. So sowing of the seeds, from that you will get a crop. From that crop we are going to harvest that seed. So the seed science that going to deal, or they are responsible for production of seed from seed. So for seed to seed activity, the seed scientists they need help of the various people, because the seed production that involve land selection, their crop management activity, crop protection activity, and then crop purity maintenance activity, then harvesting. Then after harvesting we have to do that post harvest operation like processing, cleaning, grading. Then after that we have to go for that storage. After storage we have to do that marketing. So for seed, seed is a very important input. So we have to get a appropriate quality and genetically pure material. So for that purpose we are in need of the help of the breeders. After that, for land selection we have to need the help of the soil scientists. For not only land selection, for giving appropriate nutrients to the seed crops we need the help of the soil scientists. After that, for total crop management activities we need the help of the agronomists. For control of the pests and diseases we need the help of the plant protection scientists. After harvesting we are in a position to do that cleaning and grading. So that is mainly for ensuring the physical purity of the seed crop. So for that purpose we need the agriculture engineers help. After that, for storage also we need again that engineers as well as that entomologists and pathologists, because during storage there is a chance for pest and disease occurrence. So to control that one we need the help of the plant protection scientists. Then after storage is over, as and when that demand is there for your seed material, we have to do that marketing also. So for doing marketing we need the help of the social scientists. So seed science, it's not a separate science, it's a multidisciplinary science. It's a combination of the various sciences. So that is the thing. So seed technologist, what is their role? So the scientists, they deal with handling of seeds towards prosperity, towards supply of the quality seed to the farmers. So with that definitions, now we are going to see some of the quality parameters of the seeds. So whenever I am talking about that seed, many of you may in a confusion. What is the difference between seed and grain? Whether both of them are same or anything difference is there. The another thing, for seed, almost all the farmers, they are paying more price when compared to purchase of the grain for consumption purpose. Say example, in the case of paddy, in the case of IW ponni, if they purchase the paddy, whole grain paddy as such for consumption purpose, means that will be cost around at the maximum of 20 rupees per kg. Suppose the farmer, they purchase IW ponni seed, means in that case minimum they have to pay 35 rupees to 50 rupees. So 20 rupees difference between that seed and the grain, the purchase price. Why is it so? What is the speciality in the seeds? So these are the questions arises in your mind. Definitely you are paying that 20 rupees extra, no? So that much worth is there in the seeds. So that and all we are going to see one by one here. Actually seed is not a seed, either it's a seed or a grain, it's not an individual unit, it's always mass. So whatever that quantum of material harvested from 1 acre, we are going to call it as a seed. But only one seed alone is not going to be there. So around 2000 kg of seeds will be there. So the seed is always represented in the name of seed lot. Seed is not an individual unit, seed is a mass. So here I am introduced one word, seed lot. If it is a seed lot, means you must know what is seed lot. So seed lot is the harvested cleaned quantity of a variety. One seed lot means that should be of known variety, that should be harvested from a particular field. Say example, I can give you one example. In the case of paddy, the popular variety is a IW ponni, improved white ponni. Suppose you are raising that improved white ponni in 1 acre in one particular place. Then more than 50 meters away from the first field, you are going to raise IW ponni in another acre. The date of planting and everything on the same day, the date of harvest also same. So can I mix these two produce and make it as a single lot? So not permitted, because the distance between these two fields exceed more than 50 meters, means there is a chance for soil property occurrence, difference in soil property occurrence, and there is a chance for some sort of variations occurrence. So under that situations, whatever that material you are going to harvest from that particular first field, you have to keep it as a separate lot. The another one and another lot. So this is a thing. Immediately you will ask one more question also. I have a field, 1 acre of area. There I am going to raise IW1E. Then nearby, within that 50-meter distance, I am going to raise another crop, another variety, that is a Dr.T.Eevera, that also a paddy variety. Can I mix these two? You should not mix. So IW1E is a one variety that have its own unique characters. Dr.T.Eevera is even though it's a paddy crop, that is totally different, that have another kind of character. If you mix these two, definitely you will have a mixture of seeds. So here that the genetic purity, so that genetic purity I am going to tell, so that will become a very question mark. So whether it is within the 50-meter distance or away from the 50-meter distance, if it is a two different variety, for both the variety you have to maintain on a separate seed lot. So that is a thing with reference to that seed lot is concerned. So the definition for seed lot is a seed lot is the harvested cleaned quantity of a variety, only one variety, or crop specific to harvest. Paddy IW1E means that is a separate lot that should be harvested from one unit area. So that 50-meter distance, that rule and all applicable. So the crop specific to harvest and the place of production also. Say example IW1E, you are raising in Tanjavur, and at the same time you are going to raise that crop in the Pudukkottai. So after harvest of both the material can be mixed means you should not be, okay, because even though both are not same variety, because of that change in location, there is a chance for some sort of a developmental variation. So to avoid all those things, better we have to keep that material separately, this one also separately. This is the first and foremost important property with reference to that seed is concerned. Then these are all the different quality parameters of the seeds. So seed should be physically pure. So physically pure means, so here we have to ensure that physical property like size, shape, color, then that should be free from inert matter, that should be from other crop seeds. Suppose the seed is mixed with the some soil clods or plant debris, mean, is it possible to have a uniformity with reference to size and shape of that material available in the lot? Definitely not. We cannot maintain, because that seed will be in one shape, that clods or plant debris will be another shape. So if you look at that material, that will be a heterogeneous nature. It is a mixture that never attract your customers, never attract the farmers. So we have to ensure that physical purity. So we have to ensure that uniformity with reference to size, shape, color. So for this purpose, we have to do that cleaning and grading operation after harvest of the seed material from the field. So during cleaning and grading, we have to remove all the inert matters, and that whatever the crop seeds are available other than your seeds, and all those things need to be removed. Say example, the paddy seed lot is mixed with the maize, means maize will be one size, paddy will be one size. So at the time there won't be any uniformity with reference to size and shape. So at the time we have to remove the other crop seed material and all. So the removal of the inert material and other crop seed is normally known as cleaning. So other than seed crop, whatever that material is available in your harvested produce, we have to remove through the process of the cleaning. After that, within your seed also lot of variations going to be there, because you are cultivating that your seed crop in the open field condition, so somewhat uncontrolled conditions. So there will be a heterogeneity with reference to soil fertility and irrigation water received by the different crop at a different level. So everything, some non-uniformity will be there in the field level. So this and all ultimately get reflected in the resultant produce, that is in your seeds. So some of the seeds are fully packed with nutrients, some of them are chappy, some of them are partly filled, some of them are damaged by the inside, some of them are damaged by the pathogen. So this and all make your seed more of heterogeneous nature. So again this also we have to sort it down, then only you can ensure uniformity with reference to size and shape and color of your seeds. So the first part is cleaning, through that also you are going to ensure that physical part of purity. The second aspect is grading. So through grading process, with the help of so many instruments, you can make your seed lot more of homogeneous by the way of segregating your seeds based on one physical property at a time. First, you can separate your seeds based on the weight. So for that purpose, we have a specific gravity separator. And then after separation, based on the weight, then you can go for that separator seed based on the separation of the color, based on the size, based on the shape. So if you can follow one by one after another, definitely at the end of the grading process, you will have a seed with proper physical purity. So that is a thing. So that is the first aspect, seed quality aspect. And then the next one is, so whatever that material you are having at the end of the cleaning and grading process, that should be a germinable. So this is an important thing. What for we are producing that seeds? The ultimate aim is, so this material will be used as a source for raising of the next generation crop. So under that situation, your seed should be a germinable. So here so you will be get confused with the viability. So what is viability and what is germinations? So I can tell you clearly, if you say one seed as a germinable one, means that the germination is defined as the ability of the seed to give rise to normal seedling under favorable conditions. Normal seedling, that word is underlined. Favorable condition, that word also underlined. So the ability of the seed to give rise a normal seedling. Normal seedling means the seedling should have all the essential structures like primary leaf, pucka stem, pucka shoot and pucka root, that is a primary root and secondary root. Further, that seedling show the symptom of further growth and development. So that seedling alone is considered as a normal seedling. If at all any seedling have a damaged symptoms, damaged root, damaged leaf or damaged shoot, or any decay symptom, rotting symptoms, any curling, any twisting, any deformations are recorded, those seedlings and all considered as a abnormal seedling. Even though that seed is gave rise that abnormal seedling, we have to consider that seed as a non-germinable or equal to dead seeds. Okay, so this is a thing. Again, another word, favorable condition. So normally the germination is tested by giving ideal condition for occurrence of the germination related event. Mostly for tropical crops like our paddy and ragi, green gram, black gram, this and all, international seed testing associations, they are responsible for formulation of the seed testing guidelines. So they given some guidelines. Apart from that, in Indian Seed Act also they given guidelines and favorable condition for checking germination status of the various crops are given. In general, most of the crops we have to maintain 25 degrees Celsius temperature and 1150 lux light intensity, and late humidity also we have to maintain 95 plus or minus 2%, and moisture content also we have to maintain 60% level, so throughout the period of germination. So these are the favorable conditions. So under that only germination test will be conducted. At the end of the germination test, the seed they produce normal seedling, means we can consider that particular seed as a germinable one. If it is not able to produce, that total seed is decayed, means we have to consider as a dead. So but if at all the seed produce some abnormal seedling, means again that seed will be considered as a dead one. Okay, so that is the thing. Viability means it's a degree of aliveness of the seeds. That viable seeds may produce a normal seedling, or sometimes that may produce a abnormal seedling. But if it is a germinable seed, means that always produce normal seedling. So that is the difference between the viability and germination. So for prescribing the viability level of the quality seeds, better we have to use the word germinations, germinable seeds. So seeds should be germinable. Another character also there, that is a highly vigorous. So here I am introducing another terminology, that is a vigor. What is vigor? Is there any difference between vigor and germination? Yes, difference is there. So as I already told you, the definition for germination is production of normal seedling under favorable conditions. But for the definition for seed vigor is production of normal seedling, that is the ability of the seed to give rise normal seedling even under unfavorable conditions. Any abiotic stress condition or biotic stress condition. Abiotic stress means that is a drought situations or salinity, sodicity, or any kind of stress. Even under that unfavorable condition, the seeds are able to give rise normal seedling, means that is considered as a more vigorous. So here, agriculture point of view, our field is more heterogeneous. There is always unexpected stress occurrence event will be occurred either at the time of germinations. So for our cultivation purpose, open field cultivation purpose, we always demand seed with more vigor. So we should be worried about that vigor, because germination and all we are testing only under the favorable condition, whereas that seed vigor, that is connected with the ability of the seed to give rise normal seedling even under that unfavorable condition. So seeds should have more vigorous. Then periodicity of germination should be less. Okay, that is the time taken to give rise the seedlings. Days to emergence. Suppose if it is a early emergence, means that clearly indicate that the seed is totally devoid of any problem. So the seed is fully packed with nutrients. All the nutrients are not degraded, means immediately that will enter into the metabolic activity related process that will produce that seedling immediately. If at all any problem is there, at that time only the seed will take more time to give rise a seedlings. So that and all not good. So with reference to quality angle, the periodicity of germination should be less. Then seed germination should be uniform. Okay, suppose you are sowing 100 number of seed, means all the seeds should be emerged on the same day. If it is emerged on the same day, means the further crop management activity will be very easy. Say example, you are sowing 100 number of seeds. After that, 25 number of seeds emerged on day 4, fourth day after sowing. Another 25, 10th day after sowing. Another 25, 15 days after sowing. Another 25, 20 days after sowing, means during maturity period you will have a crop with a different stage of the development. At the time you will be in trouble, whether we have to wait for the remaining crop to attain maturity or we can harvest. If you go for harvest, only you can harvest only 50%, and the yield will be obtained only from the seed at maturity. Suppose the crop at flowering or vegetative stage, that won't give you any yield. So there is a yield loss will be there. So because of that, seed germination should be uniform. That also another quality parameter. The above all, seed should be free from pest and disease attack, particularly the fungal, virus and bacteria. Here that the virus is able to survive, because seed is a living entity. Virus is applicator pathogen. So if it is a grain, there is a question of survival of the virus, whereas seed, if at all any seed borne viruses are there, definitely there will be survive, because seed is a living entity. The place of surveillance may be monocot in the case of a embryo, whereas in the case of tricot, both the primary embryonic axis and cotyledons are living. So in all the places we can expect the presence of the virus. So that the seed should be free from pathogen, or otherwise what will happen? Your seed itself act as a carrier of pathogen from one location to another location. So we have a very vast history with reference to seed transmitted diseases from one country to another country. We will discuss all those things in the seed export regulation later lectures. So the seed should be free from any pest and diseases, so that is very very important. After then, seedling should be identical to its mother. So this is an first and foremost quality parameters as far as that seed is concerned. So genetically pure. Say example, you are raising a crop, IW ponni, you are using that IW ponni seeds, and that is sown in the field. Whatever that crop come out of that seeds through that germination process, everything should be of IW ponni. Then only we can consider that particular seed is a genetically pure. If at all any other variety arises, that clearly indicates whatever that seed you are used, that is not a genetically pure one. It's a mixture. Normally, if it is a variety means, normally that should have a homozygous nature. Variety means it's a homozygous nature. Homozygous nature means almost all the plants are morphologically they are identical to that of the mother plant. But all any variations or deviations, we can say some production defects are there. The defects are that pollen contamination. The previous crop is contaminated with the other variety of the same crop. So we have to avoid that one. So we have to ensure that the genetic purity. So whatever that seed we are going to use, that produce the seeds of their original characters. There should not be any deviations or variations. There should not be any heritable variations. Sometimes the height and the breadth and color of the leaf that may be get affected, that and all normally caused by the environmental issues. Again, that things and all restricted to that particular generation alone, no need to bother about that. That character is appeared in the next generation also means we should pay attention. Some kind of variations are got introduced in our seed material. At the time we have to go for purifications. We have to check that homozygous nature of the material. So the seed should be genetically pure. So normally, particularly in the case of a cotton, we are getting a PT cotton hybrids. If it is a PT cotton hybrid means all the plants. So you are sowing that PT cotton seeds, 1000 seeds you are sowing. After that sowing operation, you are going to have a 1000 number of plants. So if everything is PT means all the PT all the plants expected to have a insecticide. I mean that American foulworm resistance. If at all any non-PT material is mixed in your seed lot means, say example 2 plants. The 2 plants don't have that insect resistant character. At the time that will invade that the pest. Once the pest enter and the population get filled up, that remaining resistant variety also become a susceptible one. So this kind of problem will occur. Similarly, if it is a genetically pure means, all the plants will attain even flowering, even maturity, everything we can expect. Say example paddy means the flowering period is 8 to 12 days. Within 8 to 12 days period of time, whatever number of the plants are available in your field, everything will be comes to flowering. That and all we can know. Suppose if it is a mixture, there is a prolonged flowering. So on within, instead of completing that flowering within 8 to 10 days period of time, that suppose that variety is mixed with the short duration mean, that will comes to flowering early. Your variety is a long duration variety mean, that will comes to flowering after 20 days or something. So there is no uniformity in the field level. The stage of development also there will be a problem. So these are all the things are there. So because of that, we have to ensure genetic purity also. Genetic purity means it's a true to time. Seed should be true to time, identical to that of the mother plant. So here all the round of multiplication we have to ensure the homozygous nature of the material. So that is a very important thing. And then another parameter, that is seed should have a optimum moisture content. So immediately after cleaning and grading, most of the farmers they are not going to use the material for sowing. Immediately after harvest we cannot use, because minimum we have to wait for 1 or 2 months until that the field again get prepared. But in our case, for Tanjavur and all, we are receiving water mostly in the month of September. We are take up a cultivation of the paddy that will comes to harvest in the month of the January. After January there will be a summer, there won't be any water available, so we cannot take up cultivation immediately. So next, what all that water is released in the month of June, the farmers will take up a cultivation Kuruvai crop. So here, and that water is available, everything is bakka. In that case also we had to wait for 6 months of time. Water delay opening get delayed from January to September. We are in a position to store the seed material. So minimum 6 months to maximum 1 year. In case of season failure, at the time we have to extend the storage life for the 2 years also. So throughout the period of storage, whatever that quality parameters so far we were discussed, everything need to be preserved. Is it possible to preserve? Because the seed is not connected with the mother plant. Whatever that stored food materials are given at the time of harvest, that is a food material for the seed to survive. After survival, at the time of germination also, for giving rise that root and shoot, that whatever that food material stored in the cotyledon or in the endosperm, that are alone helpful for the seeds. So here that the point is, if you are going to store your seed for longer period of time, means you have to reduce the metabolic activity of the seed material. So metabolic activity is reduced, automatically the seed will survive with minimum respiration and related activity alone. If it is so, the energy is conserved. The conserved energy will be slowly utilized for its survival, as well as at the time of the germination also. So for reducing that metabolic activity at a minimal level, what we have to do is we have to reduce or arrest unwanted hydrolytic enzyme formations, that is lipid degrading enzymes and protein degrading enzymes and carbohydrate degrading enzymes. Everything is there. So everything is get activated, automatically that will spoil or degrade the food material available in the seeds. So that will make that a seed will lose its food material as early as possible in the storage itself. So to inactivate or to regulate all those enzymes at a minimum level, we have to reduce the moisture content to the optimum level. So in the case of orthodox seeds, you can go for reduction of the moisture content as much as possible. So you can reduce that moisture content to the level of 6 to 10%, because orthodox seed is desiccation tolerant. So every 1% reduction in the moisture content, that storage life get double. Like some thumb rules are there. So this and all we can discuss then breath in the seed storage section. Whereas in the recalcitrant seeds, and that is a desiccation intolerant. So in that case, necessarily you have to maintain 17 to 30%. So because of that higher moisture content, here that the storability period also hardly a week to a month period of time. So we cannot store these kind of seeds for longer period of time. So here the point is we have to reduce the moisture content. So once you reduce that moisture content, the seed hardness also increase. That will not permit any insect or pathogen to attack that one. Suppose the moisture content is more, the tissues are somewhat soft, so at the time that insect and pathogen will attack, that also create a problem. So by way of reducing the moisture content, we are going to minimize the metabolic activity, and also we are going to make our seeds not amenable for the pest and disease attack. So this is also very important one. Then seed should not have any mechanical damage, because now we are using that cleaning and grading related machineries. At the time of cleaning and grading, there is a chance for occurrence of the mechanical injury. But on any mechanical damage, seed will lose its viability, because to repair that damage, the seed in a position to spend their stored food. So in the repair process, the seed is succeeded means viability will be there, but what about that stored food that will be available very less. If you sow that seed in the field level, definitely that will seed will produce a abnormal seedling or less vigorous seeds that were not able to survive. So because of that, at any cost, we should not induce any mechanical injury to the seeds. Then seeds should have a high storability. So these are genetic characters we have to ensure. We have to breed, or we have to develop a variety with long storability period. And the above all, for attracting more customers towards a purchase of your material, seeds should have a luscious. So ultimately the seed will have a better marketability. So these are all the things I wanted to convey to you. In the next class, we are going to discuss about the matter related to the difference between that seed and grain and all.